Okay, so now we're going to go over how to graph. With these graphs, we are going to use what we call a parent function table. So wherever your vertex is, that's basically moving your parabola left and right, and then your a value is going to make it narrower or wider. But other than that, we're using the same basic function where we have an x squared, and then we just need to move that x squared left and right, and then multiply it by our a value. So we're going to use what is called a parent function. To do that, there are kind of 5 steps that we're going to follow. The first thing that you are going to do is find your axis of symmetry. So in order to do that, you need to know what type of form your equation is written in. And this one is standard form. When your graph or your equation is written in standard form, you're going to use that negative b over 2a. And make sure you're careful with the negative signs in here. So a is -1, b is 2, and then c is -2. So for this one, we would have x equals -2 over 2 times -1. So our axis of symmetry, this would all simplify to -2 over -2, and that would be +1. So that's our axis of symmetry. The next thing we need to do is step 2. We need to find our vertex. So for your vertex, you're going to take that x value from your axis of symmetry, plug it into your equation. So we're going to find f of 1. With this one, when we plug that in, we'll have a negative and then 1 squared plus 2x minus, oh, sorry, I forgot. We're plugging in our 1 value, and then -2. This part of the test is going to be no calculator, so you will need to know how to do this without a calculator. And I just wanted to give you that heads up so that you are prepared when we take the test. All right, so now if we solve this problem, the 1 is being squared, not the negative, so it's still going to be negative. And then 1 squared is 1. 2 times 1 is 2, minus 2. 2 minus 2, those cancel each other out to be 0. And that would leave us with -1. So our vertex is going to have the point 1, -1. That brings us to our third step. And this is something that's probably new and unfamiliar. We're going to do something that's called drawing your new axis, or your new x and y axes. We're going to draw those through our vertex. So we're going to go over to our graph now. We're going to plot our vertex, which is at 1, -1. And for drawing your new x and y axis, I would recommend using a highlighter or a pen of different color that's not black. And these new axes are not part of the graph. They're going to be used as a tool to help us graph a little bit faster. So we're going to draw a horizontal and vertical dashed line because it's not part of the graph. If it was solid, that's saying it's part of our graph, and we don't want that to be the case. Okay, these are our new x and y axis. So we are going to use these to plot the rest of the points on our graph. And every single graph should have 5 points to get full credit. After you have all of those x and y axes plotted, now we are going to use our table. So we're going to make a table. So right now, all we have used is our vertex to move our graph over 1 and down 1. We are still going to be using an x squared value. So we are going to use this exact same table every single time. We're going to start with an x value, then we're going to square it, and the last thing we need to do is multiply that x squared value by our a value, because that will make our graph either narrower or wider. In this one, we already know a is -1, so we have that information. Now you can pick any number to plug in, but I recommend staying consistent so that you can be more confident when it comes to a quiz or a test. I always use the number 1 and then the number 2. I like to keep it consistent, sticking with those. So these first two columns should be the exact same every single time you make a table. So if x is 1, 1 squared would be 1. And then we need to take that 1 and multiply it by our a. So 1 times -1 is -1. Next, we're going to take 2 and square it. 2 squared is 4. And then we'll multiply that 4 by -1. And that gives us -4. Okay. Now, when we are plotting or using a coordinate grid, we only need 2 values. We are only going to be using the values that are on the outside of this table. So we are going to plot these points from our new origin. So our new origin was our vertex. So we're ignoring the x and y axis that we started with. We are now going to be looking at the ones that I drew on here with the dashed highlighter. So for the new origin, let's grab a pen to plot our points. We are going to have our first point at 1, -1. So from that new origin, I'm going to go right 1, down 1, plot a point. Then our second point is going to be at 2, -4. So from our new origin or vertex, I'm going to go right 2 and then down 4, plot a point. All right. Now remember, x equals 1, that vertical line going up and down is our axis of symmetry. So every point that we have on the right, we should have a point on the left that is the same distance away. So this first one that I drew here off to the right was 1 away, so I'm going to draw another point that's 1 away in the opposite direction. Same thing down here. This one is 2 spaces away, so I'm going to go 2 spaces away in the opposite direction and plot another point. This gives me the 5 points on my quadrilateral or my parabola. So then I can draw the curve and then I am done. So this would be an example of a graph that has imaginary solutions. All right, next we're going to go over how to do this when it is in vertex form. The only thing that's going to change is how we find our axis of symmetry and then our vertex. That's the only thing that's going to change, but we are still following those same 4 steps. Finding the axis of symmetry and then your vertex first. So first one, axis of symmetry. This one in vertex form, we just have x is equal to our h value. And in this one, h is equal to +3. Oh, sorry, I don't know where that line came from. Okay. Then we're going to find our vertex. Our vertex, let's get rid of that line. Where did it come from? There we go. Our vertex in vertex form is hk. In this one, we already know h is 3. K is going to be equal to -2. Once we have our axis of symmetry and our vertex, the third thing you are going to do your new x and y axis. So first we'll plot that vertex at +3, -2. That's going to be our new origin. So we are going to use our new x and y axis going through that point. And again, these should be dashed because they're not part of the graph. We're just using them to help us guide our way to drawing our parabola. Once you have that, step 4 is to make your table. And remember, your table should be the same every single time. So we are going to, except for the last column. So we're going to start with our x value, our x squared, and then a times x squared. And in this one, if we look, our a value is the number in front of the parentheses. A is equal to 2. So our graph is going to be narrower than last time. I'm going to pick the exact same values for x as before. So I'm going to plug in 1 and then 2. Then we can go through and fill in our table. So we need to figure out what 1 squared is, which is 1. And then we take 1 times our a value of 2. That is 2. Then we move on to our x value of 2. 2 squared is 4. 4 times 2 is 8. And we only need the outside columns. That is what we are going to use to graph our new points. So you're going to plot these from our new origin. So our first point here is going to be at +1, +2. So from our new origin, I'm going to go right 1 up 2. Plot a point. Then our second point was at 2, 8. So from our new origin, I'm going to go right 2 up 8 and plot our second point. That gives us half of our parabola. Now remember, the axis of symmetry is going to be used to help us reflect the points over. So this top point up here was 2 away from the axis of symmetry. So we need to go 2 in the opposite direction and plot a point. And then this other one towards the bottom of our graph was only 1 away. So we need to go 1 in the opposite direction on our axis of symmetry to plot our last point. Then we draw our curves with an arrow and we are all done. With this one, they're asked about the type of roots that we have. So if it goes through the x-axis, it's real. If it does not, they are imaginary. This one ends up giving us real roots. If they ask what the real roots are, that's when you're going to put x equals, and then whatever the x value was, where it crossed the x-axis. So this one, it crossed at 2 and 4. So we would write down x equals 2, x equals 4. And that would be the answer for the roots. Okay, our last graph, this one is in intercept form. So for intercept form, remember that tells us what our P and Q values are. These are always the opposite sign than what is in the equation. So both of these are positive. So starting off with finding our axis of symmetry, we're going to have x equals 3 plus 1 over 2. And this one, 3 plus 1 is 4. 4 divided by 2 is 2. Then next, we need to find our vertex. Okay, before we do that, one thing I want to go over, for your axis of symmetry on these, if P and Q, if one of them is odd and the other one's even, so when you add them together, if you get an odd number, you're going to get a lot of 0.5s in your axis of symmetry. So if you don't get a whole number, don't panic. You are still probably doing it correct. You are just going to plot in between the whole numbers on your coordinate grid. So if you get a fraction or a decimal, don't freak out. Just keep going. You are probably doing it correct. Okay, so then to get our vertex, we're going to plug in that x value of 2 and solve for y. So x was 2, and we would do minus 3, and then plug in our other x, 2 minus 1. So this is going to end up being -1 times +1. And when we multiply those together, we get -1, making our vertex at 2, -1. Then for step 3, we are going to draw our new axes, new x and y axis. In order to do that, first you plot your vertex, and this one should be at 2, -1. And going through that line, we are going to, or through that point, we're going to draw a vertical and a horizontal x and y axis that we are going to use. They should be dashed. Do not draw these solid. Once we have that done, then we make our new table of our values. So remember, your table should be set up the same every time, starting with your x squared, and then your ax squared. I always use 1 and 2 for my x values. So then we can start filling in our numbers. If we have 1 squared, that's 1. Then we need to figure out what our a value is. For these ones, a is the number in front of the parentheses. When there is no number, that is just like having a 1 up front. So in this one, a equals 1. So nothing's going to change from our second to our third column because we're just multiplying by 1. So then if we move down to our x value of 2, 2 squared is 4, and 4 times 1 is 4. And when you are graphing, you only need 2 values, so we don't need this middle column. We are just going to use the ones on the outside. So our first point from our new vertex, so again, remember you are plotting from your new vertex. The first one is 1, 1, so we're going to go right 1, up 1 from our new vertex. Then our second point is at 2, 4. So from our new vertex, we're going to go right 2 and up 4, plot our point. That, again, gives us half of our parabola. We then are going to reflect them over to the other side to get the other half of our parabola. So this point at the top was 2 spaces away. We're going to go 2 over to the left and plot our second point. And this graph, or the second point in the middle, was only 1 away, so we'll go 1 in the other direction as well. Once you have that, you can draw in the last part of your parabola. Looking at this graph, we can tell that it has real roots because it goes through the x-axis, and those roots are going to end up being equal to 3 and 1. And if you look, you can tell those are your P and your Q values from our equation. And that's why it's called intercept form, because the equation shows us exactly where those intercepts are going to be.